Hello everyone. So we come to the sixth module of the subject Human Factors Engineering. So in sixth module we will be looking at the various placement or locations of various controls and in what way we should arrange various controls in a room. What are the parameters to be looked into? All these aspects we will discuss in this module. So this is the first session on module 6, and in this topic we will discuss on general location of controls and displays within a workspace. So first we will look into visual displays. So the normal line of sight for an individual is usually considered about 15 degree below the horizon or below the normal reference line. So the area for most convenient visual regard has generally been considered and defined by a circle around 10 degree to 15 degree in radius around the normal line of sight. That is our normal area through which we can run our eyes to have a better visual display. So there's a graph in the next slide that shows the mean response time to the lights in various regions of the visual field. So we will look into that figure now. So this is called ISO response time within a visual field. You can see the different areas through which an individual can look into at a time. So this figure or the ISO response graph is drawn based on the research of two scientists who measured the subjects times of the response to a small light that flashed in various locations of the visual field. So it shows the mean response time to the light in various regions of the visual field, and each boundary in this figure indicates the region within which mean response time can be expected to be about same. That is the ISO response. That is called the ISO response time region. Now in this figure, if you see, the concentric lines tends to form oval shapes, but it is slightly lopsided ovals, being flatter above the line of sight than below. So uh, this supports our statement that our normal line of sight is 15 degree below the horizon. And the subjects in this study detected lights even towards the outer fringes of the area, but in the primary implication of this research is that critical visual displays should be placed within a reasonable moderate oval around the normal line of sight. That is the inference that we can make out from this figure. Now we move on to the hand controls. Hand controls can be classified into three, mainly controls that require force, controls that are placed on the panels, and two-hand controls. And controls that require force is based on the easiness of reach, and the best location for cranks and levers is in the front of the sitting or standing operators. So we will see a graph in the coming slides. And second one is controls on the panels, where when there are many controls and displays to arrange in a console or a panel, the use of angle side panels may place more of the controls within the convenient access. You should always go for angle size panel so that controls are within easy reach. And two-hand control process, for example, metal forming process, the operators have to press two buttons for safety reasons and to keep that hands away from the press when it is activated. To avoid accidental pressing in some operations like a metal forming process, two-hand controls are given. And some instances, these push buttons are palm operated by the palm of the hand are at placed at eye level. So this is the left one is a graph showing the relationship between maximum pulling force around such as hand brake and the controls and location of controls. So what you can make out from this graph is that from distance 0, the maximum pulling force is obtained when the distance is at least this much, that is around 70 centimeters. Distance of the x-axis is distance of handles in percentage of projected maximum reach. So this is a shaded region that shows that the best handle location for manual controls. For example, handbrake. So even it is in lesser distance, it will be the force that can be applied will be much less. So the best of the ideal location is this shaded region. And the right graph, that is preferred vertical surface areas and limits of the different classes. So here again you have different shaded regions, and we are classifying the controls into into different bases, that is primary controls, secondary controls, and preferred limit. So here zero position, this is the position of the operator, and this is to his left side, and this is to his right side. So this is the ideal location for primary controls, and this is emergency controls and secondary controls, or that requires precise adjustment, that should be placed in this region. That is around the left y-axis is in centimeters, and the right axis y-axis in inches. So you can easily make out the approximate distances that it should be, all these controls should be placed. So these are all based on different experiments and researchers. Now again another graph for food controls. So here again two conditions are shown. One is heel operated controls and toe operated controls. That again is marked for maximum area and optimum area. So you can easily make out what is the convenient distances, preferred distances for each of these applications. A specific arrangement of controls and displays within a workspace. Uh, Mainly, we will always go for the principle of sequence or function. So, controls or displays will be based on the sequence of operation or the function that is intended to that they are intended to perform. When there are common sequences or at least frequent relationship in use of components, the layout usually should be as to facilitate sequential process, as in hand movements or eye movements. And when there are no fixed or common sequences, the components should be grouped on the basis of function. That is the general rule. In such instances, the various groups should be clearly indicated by borders, colors, or other means. We have already looked into color coding and compatibility, etc., in our first and second modules. When relevant, compatibility principle should be followed in arranging the components. So mirror arrangement in some displays has its advantage and also its disadvantage. So mirror arrangement was used in some nuclear power plants, especially that having two reactors, and in some underground mining equipments. But if the same panel is being used by the same operators, then mirror imaging should be avoided, because it was found by studies that the emergency response and the completion times was less for mirror image arrangements than a non-mirror arrangement. So this result shows that the mirror imaging should be avoided if possible in designing pairs of control panels that will likely be used by the same operators, because it can lead to ambiguity, and it can lead to operating pushing of the wrong button. This was a graph plotted on the basis of trials and a response time in the case of mirror image and non-mirror image. So obviously you can see that the non-mirror image arrangement has a much less response time. That is, it is more quicker, or the operator is more confident in making it non-mirror image arrangements. Now we come to the next portion, that is spacing of control devices. The control device should be adequately placed so that we can avoid the touching errors in the use of knobs of various diameters. And this is shown in the figure next. In this instance, the figure shows that errors drop sharply with increasing distances between knobs up to 1 inch or 2.5 centimeters. and if we are increasing it much bigger than that, then the performance is at a slow rate. So the ideal distance is about 1 inch or 2.5 centimeters. This is a graph showing the frequency of inadvertent touching errors of knobs and various diameters as a function of distance between knob edges. And you can clearly see the percentage of trials on the y-axis and distance between the knobs. Different in the right side you have different category of buttons, and what is the and based on the use, that is randomly used, sequentially used, you have different distances that should be maintained. For example, knobs, push button, toggle switches, crank levers, or pedals, etc. Now we have general guidelines in designing individual workplaces. So the first priority should be primary visual task. Second one is primary controls that interact with the primary visual tasks. Third priority should be given for control display relationship. That is, put controls near the associated displays, or use compatibility criterions. And the fourth priority should be arrangement of elements to be used in sequence. Fifth one, to conveniently locate the elements that are used frequently. And the last one is consistency with other layouts within the system or other system. So these are the 6 priorities that should be given in designing an individual workspace.